Great, so thanks a lot. I really appreciate being here tonight. Who here has applied for a job? That's it? That's what we're going to be talking about, is how to use neuroscience and data science to help people find their best suited career, especially early on in their career. So more importantly, how many people, when they were looking for their first job out of college, how many people had a really not so great experience? Wow, okay, lucky crowd. We usually get more hands than that. This is a more technical audience than sort of the broader universe of job seekers. So keep in mind when you're thinking about this technology that this applies to essentially any kind of occupation that you could think about, not just technology. So, isn't that working? There we go. Got it? Okay, great. So essentially, Pymetrics is helping match people to careers bias-free. That's our tagline. And because we have wonderful technology, but sometimes it doesn't work that well, we have a human that's going to be advancing the slides for us. Great. So what is the problem that we're trying to solve? So access to candidates and job opportunities is no longer the problem. There's LinkedIn, there's Indeed, there's essentially the world of information has arrived to the job market, and access is now no longer the problem. So what is the problem? The problem is matching. And again, keep in mind, you guys are a very technical audience. It's a potentially, easier problem to solve within that audience. This is really, think of the broad swath of careers where no hard skills, so to speak, are involved. And it's really about figuring out a soft skill match to a position, okay? So how do you do that? The average recruiter gets 250 applicants for every job that they post. And they had basically used one of two strategies. Either they completely ignore all the resumes that come their way, and I've had people tell me that, and then they just use employer referrals and elite school recruiting, which is one strategy. Or else they use the resumes, and if it's a person doing the scanning, they'll, on average, scan it for 6 seconds. So think of how much information and how well your information processing is working if you're looking at a piece of paper for 6 seconds, okay? Or they use an applicant tracking system to do some sort of very basic keyword search and just rejecting them based on keywords, okay? So that's really the state of affairs that we're thinking about in the sort of entry-level, early-stage career world right now. And that's to decide who to interview. So the technology Pymetrics has developed is not to replace interviewing or any kind of human-to-human interaction. It's really that initial decision-making point of who do I even bring out of these 250 people in to interview, because you're not probably going to interview all of them. And it should surprise nobody that as a result of this essentially lack of matching or very rudimentary matching, 30 to 50% of first-year hires fail. That's sort of just generally. And there's also gender and ethnic bias in the process, and that's been pretty well documented. So what is the solution that we're proposing here? So my background, my co-founder's background, who's not here today, we're both neuroscientists, and my co-founder is a data scientist. We met at MIT when we were using these technologies that I'm going to propose that we're now using for career matching in brain imaging research, okay? And so what we learned in our 10 years at Harvard and MIT doing brain imaging is that if you collect better, more objective, more high-density data on people, you can actually do a better job of predicting research outcomes. That was what we were doing back in the lab. And now what we're doing is employing that same high-density objective data to look at career outcomes. That's essentially and building a matching system for that. And again, last but not least, just want to emphasize that all these algorithms are also ensured to be bias-free so that we're not perpetuating any kind of unconscious or conscious bias in that. So what do I mean by better data? And we'll get into this in a minute. But essentially what I mean is that we're using, we call them games. Back in our scientist days, we would have never called them games. We would have made a very horrible sounding, onerous name, but we used to call them scientific exercises. Now we call them games. But essentially they're activities that you perform on the computer that track your behavior and then map it to some cognitive or emotional personality trait that has been deemed important in human beings, such as memory or attention or planning on the one hand for the cognitive traits, or how well you identify emotion on someone's face, or how well, or what are your risk conditions, or how effort-seeking are you. things of those nature that basically neuroscientists around the globe have determined to be important aspects of a human personality makeup, personality and cognitive makeup. And so there have been games that have been developed by neuroscientists around the globe to assess these traits. And the reason they were developed was to link this behavior to brain imaging data that we were collecting in scanners to do our imaging research. Now, these games can also be used offline to do prediction. So we don't use scanners anymore. We don't put anyone in MRI machines to do this. The scanner has been removed from the equation. It's just the games. And we assess 90 different cognitive, emotional, and personality traits. And again, these are all nonverbal games, so they're not culturally anchored the way questionnaires or other things might be. So that's the data part. And then the matching algorithms, essentially what we're doing is we're to figure out what traits are important for a particular career. You take successful examples of that career and you use data science to figure out what the important features are and you extract those. And then last but not least, part of what's kind of cool about this technology is that unlike some of the other data that people are using to predict fit in people, the games are generally not thought to have any inherent gender or ethnic bias, so they're not picking up on that if the training sample is biased. And then we do some other things as well to sort of mitigate the impact of any kind of bias in the training sample. Okay, so again, generally speaking, the initial cut from 250 to whatever number of people are getting interviewed is being done by questionnaires or resumes. Okay, and I would argue that both of these are low density and also subjective. People tend to think that resume or whatever is not necessarily a subjective piece of information. I would argue that that's not entirely true, and there's lots of pieces on there that are pretty subjective. So this picture illustrates what the problem is, generally speaking, with subjective data, which is that if I asked any of you in your room your weight, you may know what your weight is, you may not. However, putting you on a scale is really the best way to figure that out, and that's essentially what we're trying to do with collecting behavior. And the other problem, again, with both questionnaire data and even, you could argue, resume data, is that it is looking really at high-level features that have low resolution, right? So if you think of a face, and this is, faces are used, obviously, to train facial recognition software. If the algorithms were being trained on very high-level features, such as eye color, blonde hair, and such, you would probably never be able to develop any algorithms that would then predict, be able to do facial recognition. And that's sort of the analog here in matching people to careers, is that we're looking at these very high-level features, such as what school you went to, or what your leadership style is, or your passion, or something that's just very, very high level and low resolution. So what did we do in facial recognition? We basically broke down the thing that we were trying to assess into much lower level features with higher resolution, right? So we looked at coordinates for facial features, distances, and so on, and that allowed us to build software that works better than, it's not perfect, but it works, right? So that's what we're proposing here, is that instead of looking at these high-level features in people, that you break it down into lower-level features that have a higher resolution. And so I'm going to show you one of the games right now, but you'll see that we're not just looking at whether you did it correctly or incorrectly. Like, it's not a binary outcome. It's really, we're looking at the process of how you got there. So this is a very straightforward exercise, and you may have even seen it before. So it's just two sets of towers, and essentially you want the bottom stimuli to look like, oh, you know what? The things are gone. But there are three towers right here, and the rings are held on the towers. And so you essentially want this to look like that. And so what we do is you get 2 minutes, and you basically people have very different strategies of how they approach this game. Some people plan it all out. Other people have a more spontaneous way of doing this task. The whole point is what we do for the entire 2 minutes that you're doing is we look at your planning or your problem-solving style, rather than just limiting ourselves to, did you get a correct answer? Did you not get a correct answer? And so what you get at the end is a readout of sort of different features that we collect and sort of where you stand on the distribution. And this information is a lot more useful in terms of building algorithms as features for building algorithms than just sort of binary outputs. So if we go back to, sorry, the slides. So that's the data side of what we're doing differently in terms of trying to optimize the matching system. And then, so again, recruiting is a challenging field for the reasons that I just mentioned, because the data that you have is not very robust, let's say, right? But even if we take that aside, I think you should, so this is a very technical audience, so this stuff is kind of, your bread and butter. But when you think about the average company that's trying to solve this problem of matching people to jobs, most of this stuff isn't something that's even within their consideration, right? So they're using very traditional methods that, again, use inflexible models that make overly strong assumptions about the data. They're obviously prone to overfitting, which is what this graph over here is showing. They tend to be run as consulting business models. And again, when you're looking at sort of more traditional models, people are really optimizing them for description of data overfitting rather than prediction, right? And again, you guys all know this, that's fine. But just to realize that the bulk of the businesses out there that are trying to do some sort of matching, however they're doing it, are kind of built on this premise. So really, this is the state of affairs, and we're trying to move it forward into a world where machine learning is actually entering the picture. So again, this is very standard machine learning stuff, but what we're trying to do is really, model the data in the most flexible manner, obviously using also cross-validation and regularization, so to avoid overfitting and really to make it plug and play, right? So you can put some data in and automate the entire process, so at the end, it's a very highly scalable and replicable process. The one challenge that we had to think about when we were doing this is that because people are interested in the features, you can't just sort of assume that you put some stuff in, something comes out, and nobody cares, right? So we actually had to take a lot of care and provide descriptive, things to actually explain what features were important and why they were important. So that's just something to think about, that it's a unique challenge in the machine learning field, that you actually have to look at the features and make them human readable, essentially. And so just going back to that slide 1 minute. So there are a handful of startups that are starting to do this type of work in the recruiting field. Many of them are focusing on the resume as a source of data. Again, we would argue that there's some problems to that, but we are one of the few that's really looking at other forms of data to move this problem forward. So then you might ask, okay, so you have a training set, and then what's your contrast group, right? Because you always need a contrast group. And again, this is something that we spend a lot of time thinking about, and anyone that's in this field has to think about. So a lot of times when people are trying to solve this problem, what they'll do is they'll take top performers in a particular occupation, whatever that is, and they'll contrast them to bottom performers, and that's kind of the standard, right? But I like to use my NBA analogy for this. If you took top NBA players and bottom NBA players and you use that difference to try to then pick more NBA players out of a general group of athletes, you'd end up with a bunch of short people, right? Because you're missing the fact that all of them are tall. And that's essentially, and again, this is very standard. This is what a lot of outfits do, is they just look at that very small difference. And what we're saying is, no, you really need to collect a baseline that is representative of the people that you're trying to select from, and use that as your contrast group. And so that essentially would be, the general pro athlete population. And in our case, it's really just a general early population group. So how does this work? So what we do, can you just go back to that one slide? So what we do essentially is the top performer group we get from an organization. They will label people as top performers. We also have our own data set of people that we use for that we've collected on our own, but we'll label people as exemplars of good fits to an industry. And then we'll compare it against this much broader pool that we've also collected. So again, the more traditional way of looking at this would be to just do the top versus bottom group. And again, it's a much simpler problem to solve, right? Because you have a well-defined in-group and well-defined out-group, and it's both balanced and clearly labeled data. So that's an easier, two-classifier problem to solve than if you have what we're currently doing, which is essentially having an in-group, which tends to be a lot smaller, obviously, than the much broader baseline group that we've collected. So an in-group would tend to be anywhere from 100 to 1,000 data points, and our baseline group is in the tens, hundreds of thousands. And then the other problem is that in that baseline group, you will often have exemplars that you don't know if they could be good at a particular profession. They may not have ever tried it, right? So there's unlabeled data in there in the sense that somebody could be in that baseline group. They could make a great whatever it is that we're putting in our training sample, but we don't actually know. So it's a more complicated problem in the sense that it's both imbalanced and there's unlabeled data in there. So that was one issue that we encountered when using machine learning to try to solve this problem. So at the end, what do you get? So at the end of all of this, you have your training set. You've contrasted it against this baseline group. And what we're able to pull out is the traits that are important for this particular set of people. We have some sort of human readable output that people are happy with. We obviously provide cross-validation and then proof at the bottom that there isn't any gender ethnic bias that's being introduced by the algorithm in this process. And so, hold on, actually, so then other interest, so then what happens to that data once you're done with it? So how it's used is, so think back to you're either looking at a resume or you've asked someone to fill out a questionnaire. That's the standard. So what we're doing is we're essentially giving somebody a fit score for a particular model. And again, usually when we work with companies, they're asking us to baseline not just one particular position, but multiple positions within an organization. So there's really a sense of not just yay, nay, but no, how does this person fit within various groups within the organization? And then after we give them an overall fit score, somebody might be curious as to, okay, exactly how does this person fit all of the different traits or features that we've extracted? And so we provide an output of that as well. And this was just to show you that. The other cool thing, we think it's cool, is we also do this from the career seeker side, right? So think of yourself, 10 years ago, 20 years ago, you were trying to figure out what should I do with my life. The most commonly used instrument is the Myers-Briggs, and it is almost a century old at this point. It's 80 years old. So we're trying to improve on that. And again, this is data that we've collected outside of working with companies, and we've looked at good examples of all of these different careers that we've mapped. And so we then give you, this is my own data, I always joke, good thing I got high fit to entrepreneurship, or I'd be reconsidering my latest career. And we've assembled all these career models, and then what we'll do is we'll give you, again, we'll match you to the model, just like we did for the recruiter, and we'll say, this is why you're a particularly good fit for entrepreneurship. So you're doing this matched model, thing. So you guys were probably wondering, does this all work? Is this actually improving anything? So again, we're a relatively new company, but this is just to give you an example of how we're getting used. So again, large Fortune 500 company trying to process essentially 250,000 people that are applying to them to get to less than 1,000, right? That's the problem they're solving for. We're the first step. And so again, as opposed to just being a yay, nay decision, we built 7 models for them. We're helping people not just pass through the first part, but also get slotted into the correct track that would be best for them. We've reduced the application time substantially. We're processing all of these candidates in an unbiased way, and we've seen early proof that the first-year failure rate is reduced. And then last but not least, a lot of people have what's called algorithm aversion in the recruiting field. And so what we've done to try to mitigate that and also to just make it a better candidate experience is that any candidate that's not passed on to the next round using Pymetrics actually gets the ability to come back to the Pymetrics pool and then get matched with other companies that are looking to hire people. So we're not just an assessment filter, we're also a sourcing platform where people can actually find additional talent. So it's a really good experience for the candidate because not only are they, in the chance that they're not being passed through, which unfortunately given the percentage that we're talking about here is fairly high, they at least get the opportunity to then get matched with other companies that they are well suited for. So again, it's not just one size fits all. And actually, before I go there, sorry. So one other thing I just wanted to just talk about really briefly is that the other really cool thing you can do, aside from matching people to models, is you can actually match models to models, right? And so, the finance industry is, contracting in New York, or so they say. And so what to do if you're a hedge fund manager that has lost your job? You come to Pymetrics, obviously. Where else would you go, right? And so what we've done is we've essentially looked at, if you are in a good fit for hedge funds, what else might you be a good fit for? Well, you can see some things up there like PE and consulting, which would be kind of obvious choices. You could say that's a duh thing, right? But what's really interesting is that actually you shouldn't go be a venture capitalist, because that's actually one of the least correlated professions, right? And then you might ask yourself, why is that? Well, it's actually really interesting. So if you look at people that are a good fit for hedge funds, they tend to make their decisions based on sort of the facts of an emotional situation, the context, versus VCs. Matt, I don't know if you agree with this, but they tend to sort of be more gut driven, as they say, and really looking at the emotional context of the situation. Then what's also really interesting, I think, is that if you look at effort for high reward versus low reward, VCs are very motivated by that sort of high reward stuff, versus the hedge fund managers, they're hedging, right? So of course they're going to put in effort for a variety of different things, including low reward situations. So it's not just matching candidates to companies, it's also just matching careers to careers. And sorry, last but not least, I just wanted to acknowledge our wonderful team. So again, we're a Series A funded startup in New York. This is our team that we put together. It's a dedicated group of data scientists, neuroscientists, engineers, and former recruiters who have helped us understand how best to solve this problem. Thank you very much.
Wonderful, thank you. And now I understand why I never got the call back from those hedge funds.
Exactly. That's what we're here to solve for.
Thank you very much. Just one quick question from me, since we're a little over time. How does the feedback loop work? Like, how do you know it works? I mean, do you have to get the data from the employer?
Yeah, exactly.
And how do you assess whether the data is reliable? Because it's this match at a company level, but it could be just a match with that specific manager of yours.
Yeah, I mean, you're right. There's always going to be noise in the feedback loop, which is something that, oftentimes you don't have to contend with. But essentially what we do is just a, A/B test of, like, before Pymetrics, the turnover rate was this. After Pymetrics, the turnover rate was that. So the other variables are left to vary, but they're varying in both cases. So.
Great. Yeah. Do we have a question? Who hasn't asked? You asked a question. Did you ask a question?
Very cool. Understand the cognitive side. Seems like a terrific machine learning problem. How do you bring in experience to the process?
Experience as in, like, I've been in a particular field for 20 years and I have this amount of experience type of thing?
Exactly.
Yeah, so I think that this solution is honestly best suited for, let's say, the first 10, 15 years of this process. I don't think it definitely can work with experienced hires, but the reason I think it works better earlier on is a couple of reasons. That's really when there's the lowest signal in your resume. I mean, if you think of, what 21-year-old people's resumes look like, is there really anything much on there that's of great help? Unless, again, you're in a highly technical field where you've got some, hard skills that you've developed, right? But other than that, the signal is very low, right? So what I would argue is that experience can be brought in, but I think that right now the problem that we're best suited to solve is really kind of like millennial hiring and under, yeah.
Hey, so do you ever worry about the homogenizing effect of your algorithms on the workforce? For example, Richard Feynman had an IQ of about 125, which is unusual for Nobel laureate physicists. Right. Alvin E. Roth, the Nobel laureate economist, was not even an economist.
Right. Well, so again, if you think of the contrast of what we're like, in an ideal world, you would meet everybody and talk to everybody and so on and so forth, right? But if you think of what we're replacing, let's say, or augmenting, think of the homogenizing effect of resume review, where somebody is scanning a piece of paper for 6 seconds and making a decision that way. Unless you think that a person is less likely to create that homogenizing effect based on that process, I would argue that that's probably untrue. The second thing I would say to that is we measure 90 different traits, right? Of the things that end up being important, it's usually maybe 10, maybe fewer than that. The remaining 80 are left to vary tremendously, right? So that also counters this idea that it's just a homogeneous sort of like Gattaca, you know, like society that we're creating. And the third thing that I would argue is that there's a lot of bias right now, right? Conscious, unconscious bias, where people just hire more of the same, right? Oh, I went to Dartmouth, you went to Dartmouth, great, you're wonderful, right? You went to Princeton, not so much, right? And that's extremely homogenizing. They're only recruiting at elite schools. That's not homogenizing. They're totally ignoring the people that went to state school so-and-so because, you know, again, they're not even bothering to process those candidates. So if you think about, and there's been tons of research to show that the more diverse an applicant pool you have, whether it's on the gender spectrum, the ethnicity spectrum, the socioeconomic spectrum, that is actually going to contribute far more to a non-homogenizing effect than having a few things that you've selected in the most data-driven way possible that actually appear to be more important than not for success in a particular field. And none of this is IQ-based. I mean, just to be clear, we haven't created another separate IQ scale. There are traits on there that predict success, like one end of the spectrum predicts success for certain fields, another end of the spectrum predicts success for other fields. So there's nothing about this that is just kind of a one size fits all. It's essentially the opposite. It's like that career map I was showing you. It's just where do you fit into the wide world of work, you know? So.
Time for one last question. I think Andrew is faster with the microphone than I am.
So just a small question.
Yeah.
Speaking of NBA players.
Yeah.
So if I want to hire an NBA player, yeah?
Sure.
And like maybe he has very good profile, like psychological profile, but is he able to play basketball,
right.
you know?
Yes, absolutely. Yeah, that's a really good point. That's an excellent point. I mean, you're right. And, you know, that is where the new test set comes in, right? We were just talking about this the other day, is like we have to, you know, train, we cross-validate and so on and so forth. But really, you don't know how well things work in real life until you put that person in a situation. And all we're trying to do is say, look, this person looks like they'd be a good NBA player. But again, there's nothing, you know, think about it. The problem we're trying to solve is that initial decision as to like who to bring in for an interview, nothing more. We're not touching the interview. We're not touching the internship process. We're just trying to make that initial process less not optimal than it is now. So obviously there are many other aspects to the hiring process that are critical and that we don't address for sure. Yep.
Okay, this is great. Thank you. There's a number of other questions, but you're going to be here right after the last talk.
Yes. Thank you very much. Thank you.
Thank you so much.